In this video, we are going to solve absolute value inequalities. So, when solving inequalities that contain absolute values, we are going to have one of two situations. We are either going to have an AND situation, or we are going to have an OR situation. So when you have inequalities that contain absolute values, their result is ultimately going to be a compound inequality. So if we're solving a normal inequality, it's just going to be 1. But if there is an absolute value in there, so here you can see your absolute value symbols. If we have an absolute value, it will be an AND or an OR situation. And we'll talk through how we figure out which of those two situations we have. So before we start solving complicated inequalities that contain absolute values, I want to talk through the two simple situations that you see on the screen right now. So this first one says the absolute value of x is less than 2. And remember, absolute value means distance from 0. So this is saying x's distance from 0 is less than 2 units. So if we stop and think about that, x, whatever it is, has to be 2 units or less from 0. And let's go to a number line for a second. So here we have 0, 1, 2, 3, -1, -2, -3. And if we think about this, if we start at 0 and we move up to 2 units away, so we start at 0 and we go in the positive direction. If we go up to 2 units, we're going to get to 2. 2 is where we are 2 units away, so we can't go past 2. So numbers like 1.9, 1.75, 1.5, 1.5, all of those numbers are less than 2 units away from 0. The other option is we go in the negative direction. We go, now we're 1 unit away, and now we're 2 units away. So what this statement is saying is that x's distance from 0 is 2 units or less away. So x has to be one of these numbers in between -2 and 2, because those are all of the numbers that are 2 units or less away from 0. So we can now visualize this, and we can see that this is an AND situation. Now if we go down to number 2, this is a little bit different. So this one, remember, absolute value is distance from 0. And this one is saying x's distance from 0 is 2 units or more. So what this is saying is that we are 2 units or more away from 0. So now we have to look for all of the numbers that are 2 units or more away from 0. So again, I'm going to start with a number line. Here's 0, 1, 2, -1, -2, there's -3, there's +3. So if we start and we're at 0, well, 1 isn't 2 or more units away from 0, and 2 is where we start being 2 units or more away from 0. So 2 is the first number we could be at, and then we could continue going to bigger numbers. So 3 is 2 units or more away from 0, and 4, and 5, and 6, and so on. And then if we go in the negative direction, if we started at -2, then -3, -4, -5, all of those are numbers that are 2 units or more away from 0. And that's what this is saying. As a result, any number in this region here or this region here would make this inequality true because it's dealing with absolute value. So here, this is an OR situation. So now that we have a better understanding of this, now we're going to use the knowledge that we tackled on this slide, figuring out what those absolute values with inequalities actually mean, and we're going to apply that to help us solve more difficult examples. So we're just going to start jumping in and solving these absolute value inequalities and kind of learning as we go, doing a bunch of examples. So you're going to start these just like you did your absolute value equations. Essentially, you need to start by getting the absolute value alone on one side of the inequality. So we're going to start by undoing what's happening to the absolute value. We're going to subtract 3 from each side first. So we have 2 times the absolute value of x minus 4 is greater than 8. Then we're going to divide each side by 2, and we find the absolute value of x minus 4 is greater than 4. So then we need to take what we just found, that absolute value by itself, and think about what this means. So I'm going to draw a little sketch over here, and we're going to talk through exactly what this statement is saying. So this is saying x minus 4, its distance from 0 is 4 or more than 4 units from 0. That's what that is saying. We are more than 4 units away from 0 when we have x minus 4, whatever it is. So I'm going to draw a little sketch here, and I have 0, 4, and negative 4. And I need to think through, okay, where are the numbers that are more than 4 units away from 0? We are more than 4 units away from 0. So that would be 4, and then numbers like 5, 6, 7. Those numbers are more than 4 units from 0. I would then have negative 4. And if I go towards negative 5, negative 6, all of those numbers are more than 4 units from 0. So I can see from this picture that I have an OR situation. I have either this side or this side. So this is telling me I need to write an inequality for each side. I'm going to create an OR. So as a result, down here, I'm actually going to write this out. So this side over here, saying x minus 4, and this region right here, in order to get this region right here, x minus 4 would need to be on the smaller side of negative 4, because that would encompass negative 5, negative 6, negative 7. That's what this region is focusing on. Or the other option is that we're over here, where we have x minus 4 is on the bigger side of 4. So notice that I have two different inequalities going on here. Here I have a less than, here I have a greater than. And that's because to get this left-hand side, we need to be on the smaller side of negative 4, and to be on this right-hand side, I need to be on the bigger side of 4. So I use this little sketch right here to help me write out both of my inequalities. This or that. I can see it's an or. So then from here, I'm going to add 4 to each side. So then I get x is less than 0 or x is greater than 8. So these are all of my values for x that will make this original inequality true. So then I'm going to go to my number line. I have 0. Here's 8. I have an open circle at each, going to the right for 8 to go towards numbers bigger than 8, and left for 0 to go towards numbers that are smaller than 0. And if I took any number in one of these regions, it would make this original inequality true. All right, so example 2, we're going to start by getting that absolute value alone on one side of the equation. So we start by subtracting 3 from each side. So I have 2 absolute value, x minus 4 is less than or equal to 8. I then divide both sides by 2, and I have the absolute value of x minus 4 is less than or equal to 4. And then what we're going to do is we're going to think through what this statement means. So what this statement is saying is that x minus 4, its distance from 0 is 4 units or less from 0. So So now I have to think of what is the region that is 4 units or less from 0. So here I have 0, here I have 4, here I have -4. And as I'm thinking this through, I think, okay, well, if I start at 0, I can go all the way up to 4, and all of my numbers are 4 units or less from 0. So 0, 1, 2, 3, etc. I can then go all the way down to -4. And again, all of those numbers are 4 units or less from 0. So this line represents all of the numbers that are 4 units or less from 0. And as a result, I can now see that this is an AND situation. I can see it's an AND situation, so what I'm going to do is I'm going to write an inequality for that as an AND. So here I'm going to stick -4 on this side and 4 on this side. I'm going to stick x minus 4 in between, and then I can see that I need to be on the smaller side of 4, and then I need to be on the bigger side of -4. So when I see that and, I'm then going to create my sandwich. And then from here I can solve this like any other compound inequality. So I'm going to add 4 to the middle, the right, and the left. So I get 0 is less than or equal to x, which is less than or equal to 8. And this represents all of my values for x that will make that original inequality true. So then from here, I can plot. I have closed circles at each with a line in between to represent all of the numbers between 0 and 8. So now we're going to walk through a few examples without the scaffolding on the screen. So remember, our first step is to always get the absolute value by itself. So we're going to subtract 8 from each side. So we have -3 times 5m minus 6 is greater than -21. We then divide each side by a -3, which I remember if I divide both sides by a negative, we're going to have a sign switch. So here I'm going to have the absolute value of 5m minus 6. My sign is going to switch, so I have less than 7. So I'm going to take a closer look at what this actually means for me. So there I have the absolute value of 5m minus 6 is less than 7. So let's pop that up here and have a little discussion about it. So here we have 5m minus 6, and its distance from 0 is less than 7 units away. So if I draw a little sketch of this, so I have 0, 7, and -7. What I think through is that I can't be more than 7 units away from 0. So I can start at 0 and I can go all the way up to, but not including 7. But I can't go further than that. If I go beyond 7, I'm more than 7 units away from 0. And then I apply that same thinking towards the -7. We can go all the way down to -7, but once we get to -7, now we're 7 units away, and if we go further, we'll be more than 7 units away from 0. So right here in the middle of 7 and -7 are all of the numbers that are 7 units or less away from 0. So then from here, I can start to see, okay, this is very, very clearly an AND situation. I can see the AND situation in there. So then I'm going to write an inequality for this with -7 on one side and 7 on the other. And then I'm going to put 5m minus 6 in the middle. And then I think, okay, 5m minus 6 needs to be on the smaller side of 7, so I'm going to put it on the smaller side of that inequality. And then it needs to be on the bigger side of -7 to be in that region. So just from having this little sketch over here, I can get my inequality written and see that it's very clearly an AND situation. So now I'm going to rewrite it over here so I have a little bit more room to play with. I'm also going to utilize keep, change, change. And then from here, I'm going to solve that compound inequality. So I'm going to start by adding 6 to each area. So those are going to cancel out. So then I'm left with negative 1 is less than 5m is less than 13. I then know that I need to get the m by itself, so I'm going to divide both sides and the middle by 5. And what I find here is I have negative 1/5 is less than m is less than 13 over 5. So here what I'm seeing is that I have fractional answers. Essentially, m can be anything between negative 1/5 and 13/5. And while that's not the nicest of answers, that is our answer in this case. So I can put these on my number line. So I have negative 1/5, 13 over 5. I then can add in my open circles due to my no line inequality. And then I know that I'm going to be on the smaller side of 13/5 and the bigger side of negative 1/5. So I have that nice line in between. All right, next example. So here we start off by dividing each side by 2 to get that absolute value by itself. So we have x minus 5 inside of the absolute value is greater than 7. Then from here I have my absolute value alone, so I'm going to kind of go off to the side and brainstorm a little bit what this is saying. And this is saying x minus 5, its distance from 0 is more than 7 units away. So if I think of numbers that are more than 7 units away from 0, I think of numbers like 8 and negative 8, 10 and negative 10. So I can draw a little sketch of what this is actually saying, and I can draw it right here if I want to. So I have 0, I have 7, and I have negative 7. And this is just my thinking sketch to help me think it through. And I know that if I'm in the positive section, the positive numbers that are more than 7 units away from 0 are numbers like 8, 9, 10, 11, etc. Then if I look on the negative side, the numbers that are more than 8 units away from 0 are numbers smaller than negative 7, like negative 8, negative 9, negative 10. So they're going to go this way. And then from here, now that I've got my sketch, I can very clearly see that this is an OR situation. So essentially, x minus 5 could be in this region or in this region. So I need to write an inequality to represent each. So if I start on the left-hand side, x minus 5, if it wants to be in this region, all of these numbers, so negative 8, negative 9, negative 10, all of those numbers are smaller than negative 7. Or I'm going to be in this region over here, and x minus 5 needs to be a number like 8, 9, or 10, or on the bigger side of 7. So now from here, now that I've got my compound inequality, all I need to do is solve that compound inequality. So I'm going to start by adding 5 to each side. So on the left-hand side here, I have x is less than negative 2, or here I have x is greater than 12. So x could fall in one of these regions and make this original inequality true. Now all I need to do left is plot this on a number line, 2, 4, 6, 8, 10, 12. We have open circles at 12 and then going towards numbers bigger than 12, open circle at negative 2 and going towards numbers that are smaller than negative 2. So the last thing we're going to do here is look at 2 special cases we need to be on the lookout for. So here, the first one, we're going to start by getting the absolute value alone. So we divide both sides by a negative 4. You should be thinking that when you divide both sides by a negative, you're going to have a sign flip. So here we're going to have the absolute value of x minus 5 is less than negative 5. And here, if we then think about what this statement is saying, this is saying x minus 5, its distance from 0 is negative 5 units or less. And you should know at this point that the absolute value represents a positive number because it's a distance from 0. It can't be negative. So for our distance from 0 to be -5 units or less doesn't make any sense. We can't be -5, -6, -7, -8 units from 0. That doesn't make sense. There's no positive number in there. And as a result, if you get a situation like this where you have an absolute value less than a negative, you can stop and you can say that this is simply a no solution case. You can see from looking at it that there is no possible solution that will make that inequality true. Nothing that you put in for x will produce something that has an absolute value that is less than -5. Now, if we look at the second example here, if we divide both sides by 3, we get the absolute value of x minus 2 is greater than -2. So this is saying that x minus 2, its distance from 0 is -2 units or more. And at first glance, this looks like the one up above, but it's saying -2 units or more. Think about things that are greater than -2. Yes, there's -1 and 0, but there's also every positive number that exists. So this is saying x minus 2, its distance from 0, is more than -2 units, or it's every single possible positive number, which no matter what you pick for x, whatever you put in there, its absolute value is going to be bigger than -2. Pick a number for x, subtract 2 from it, take its distance from 0. This will always produce a positive, and a positive number, you can put that in there, a positive number is always greater than -2. And as a result, in this case, this is an all real numbers solutions case. So be on the lookout. There might be a no solution or an all real number solutions hidden inside of these absolute value inequalities.